And there's somebody up there who's cheering for that. Well, we shall see. The fact that we've got El Nino going on right now, it's suppressed the storm season to this point in time. We didn't have any January, February tornadoes this year. We just had a long, drawn-out winter. But the calendar turned to March, and we're starting to finally warm up a little bit. But the El Nino influence is still there, so it's looking like we're going to still remain on the cool side and on the relative dry side for the coming month. Now, that doesn't mean that one single storm system might come through, and it could be next week, that might have a lot of rainfall and perhaps even some severe weather. So again, we always need to be prepared. What takes place with regard to storm formation is a pretty simple process. You've got a collision of different air masses, the warm and humid air coming from the Gulf of Mexico, colliding with the cool and dry air coming south out of Canada. And as that air pushes southward, it acts like a wedge. And as it wedges southward, it pushes that warm and moist air upward to form thunderstorm clouds. And if that contrast between the air masses is significant, then we have very strong storms develop, and oftentimes severe storms. Within the thunderstorm itself, it develops both an updraft and a downdraft. The updraft is what creates the storm, air rising upward from the ground, transporting heat and humidity upward in the atmosphere, condenses into cloud droplets, they collide to form rain droplets, and when you get enough rain droplets up there, they begin to fall down towards the ground. In doing so, they drag wind down to the ground with it. So with the downdraft, you have a combination of rain and varying strengths of wind, depending on a lot of other factors that are in play there. But that's the essential elements that are associated with a thunderstorm, updrafts and downdrafts. And it's typically the mature stage of the storm where we see most of our severe weather taking place. A typical average afternoon thunder shower in the middle of summertime will last about a half hour long from beginning to end. Severe storms, on the other hand, have been known to last for several hours, and in extreme cases, squall line complexes and or what we call derecho type events can last as much as 12 hours long and have a cluster of storms run from the upper Midwest all the way to the East Coast in the course of that 12-hour time frame. We see lots of different types of storm structures, from the single cell popcorn thunder shower that's common during summertime to a clustering of storms that might be I shouldn't say unorganized, not so organized fashion, to one that's formed in a line, our squall line, and to the supercell thunderstorm, the thunderstorm that develops rotation and causes lots of havoc when we have those taking place. So let's first off start with the squall line, because this is the type of structure that typically causes most of our severe weather here in central Indiana and really across the Midwest. And the majority of issues that we have with regard to the squall line event is that you have straight line wind damage. Now, that's not to say that you're not going to see some hail out of these, because you can see hail perhaps even up to nickel size in squall lines. On occasion, they can be some flash flood producers. It's not, actually it's fairly often, upwards to half of squall line events that may have supercells embedded or not are capable of producing a tornado. So we're going to take a look at some details from a radar perspective of what you want to be watching for. As I was talking here, you probably saw the loop running here of this bright white cloud that was approaching this stadium here. That bright white cloud is the shelf cloud. It represents the cold front, the miniature cold front that's out ahead of that squall line, which is a representation of the downdrafting and outflowing air that's at the leading edge of the storm. The dark bluish gray sky that you see behind it is the very heavy rain that typically follows its passage. And usually in association with that, you oftentimes tend to see a lot of lightning as well. From the diagram on the lower right-hand side, what you'll see here is the updrafting that takes place in the squall line event. That squall line is acting like a wedge, and so as it marches along and that shelf cloud pushes along, it forces the warm and moist air right up over the top of it. So this cloud structure right there is your shelf cloud. That's the warm and moist air riding up over the top of it, which is generating your precipitation, downdrafting, carried on back behind that shelf cloud. So again, that's what you're seeing taking place right there. In the inset on the lower left there, that's the radar depiction of what this looks like, and the dark blues represent the most intense precipitation, and the lighter blues, light precipitation. So you can see that in the case of the squall line, you usually have these most intense echoes right along the lead edge of the line. And you can see out ahead of that there, we have a cold front drawn to indicate that that shelf cloud acts like a miniature cold front. We also call it an outflow boundary because the air is flowing out from the storm. We also refer to it as a gust front because we have gusty winds occurring behind this frontal type boundary, which again is much like a cold front because it's a rain cool air that's flowing out from that storm. Now in this particular case, we kind of have an extreme example of strong winds that are flowing down and out of this thunderstorm. And in this particular case here, you can see a couple of different things occurring here. You can certainly see the rain shaft spilling downward and outward from that thunderstorm cloud. And as it reaches ground level, it's spreading air out in all directions. And some of that air spreads backwards. And notice how you see some of this is actually rising upward. Well, this entire section of cloud that you see back here to the left-hand side, you can see a well-defined cloud base here. That's the updraft portion of that storm, and that's where air is rising upward. It's lifting precipitation aloft, and that precipitation is falling here in the forward part of the storm. And again, that's all the smooth, bluish-looking gray stuff there. And you can see the lightning flashes that are occurring with that. So again, an extreme case of strong straight-line wind. That shelf cloud that precedes the squall line, it runs parallel to the ground. When it gets very close, it looks like it's running horizon to horizon, so it's literally miles and miles long. And as you can see here, they don't all look exactly alike, but they all look similar. And again, the fact that they're running parallel to the ground, and they all represent the same thing. They represent a downdrafting and outflowing air ahead of that precipitation area. Now, in this case, on the upper right, you can see the smooth bluish-gray behind it, the heavy rain that will typically follow. Here on the lower right-hand side, you can see the rain-cooled outflow air coming down here, and here's the ingest area. Air riding up and over the top, and there is your shelf cloud from this side perspective here. And the image on the upper left-hand side, now note here how the sky is kind of bright underneath and behind the shelf cloud. In that particular case, that shelf cloud kind of moved well ahead of its precipitation area. So in that particular instance, you would experience a wind shift with that shelf cloud, but the rainfall may be minutes to maybe as much as 5 or 10 minutes behind the shift of wind that has taken place. But again, they all represent the same thing, downdrafting and outflowing air. Just as you see here, air rising up and over the top of the shelf cloud, rain-cooled outflow air coming down on its backside. In this image, same thing here. This line that you see right here, that represents the lead edge of the outflow, and that's coming directly out of the screen at you. You can see behind it, the smooth bluish gray of the sky, the heavy rain that will follow. Same story here. Again, this line here, that's the shelf cloud, air rising up and over the top of this here, up into the top of the storm, precipitation coming down the rear side of that shelf cloud. Now here we have one that was out in Shelby County a few years ago, a very well-defined shelf cloud. Looks like in this particular case, the precipitation might be just a wee bit behind, at least at this particular location where the picture was taken. Now, as you look at the radar image on this here, again, this is the image that we'd normally see if you're looking at internet or if you're looking at television. And as you can see here, the leading edge here is where your most intense echoes are at. Now, also notice up here, now here's our office and the radar site right here, and over here we're in Shelby County. And notice how this segment of the line has kind of bowed outward relative to the rest of the line. It's actually accelerated more quickly than the rest of the line has. That's an area where the winds will be stronger along the entire line. Where it's bowed out the most is where you tend to find your strongest straight line winds taking place. Now there's another feature you have to be concerned about. As I may have mentioned before, upwards of half of our tornadoes come from squall lines. Just north of where it's bowing out the most is potentially susceptible area for development of a small tornado. Once again, we'll take just a slightly different look at this here. But what I want to point out now is the velocity data. So this is where we'll start talking data that you may or may not have used before. The velocity data is by the Doppler principle. It's measuring motion towards or motion away from the radar. And we colorize that with reds and greens. Where we have reds, air is moving away from the radar. And where we have greens, it's moving towards the radar. Now remember this squall line here, here's our office up here. The squall line has already moved east of us and it's moving away from us, and that's why it's painted in red. Look to the color scale associated with the image to determine how strong those winds are. And it's a very simple rule to follow. Whether you're looking at greens or you're looking at reds, where you have dark shades of color, the winds are weak. And where you have bright shades of color, the winds are strong. So in this particular case here, we're going to focus on what's taking place over here east of Shelbyville. As we start back to the rear edge of this here, we go from dark reds to lighter reds and into these kind of shades of pinkish color. So on the scale right here, we work our way up to values somewhere up around here. You can see the values of 60 and 70. Now this scale is actually in knots, but for simplicity purposes, 1 knot equals 1 mile per hour. Not quite the case, but for simple purposes, that's good enough here. So what we know then is we've got winds of 60 to 70 miles an hour in this squall line east of Shelbyville. Now remember back to what I said early on. The radar's beam gains altitude with distance. Over here east of Shelbyville, our radar beam is somewhere on the order of about 4,000 feet or so above ground. So what we know is that we've got winds to 70 miles an hour at 4,000 feet. But what we don't know is, are those winds making it all the way down to the ground? In the large majority of cases, that typically is true. But not always will that be the case. Sometimes there is an inversion that's actually below cloud base and above ground level that will literally stop and deflect that air horizontally before it reaches the ground. And so the only way that we know for sure how strong those winds are going to be is if we have some kind of wind measuring equipment out ahead of that, or we have a storm spotter that's reported to us their estimate on the strength of the wind, or maybe they've got a handheld anemometer and measuring the wind speed, or they're estimating based on trees whipping around, or they're seeing wind damage taking place.